Okay, ladies and gentlemen, welcome to this session on climate change and opportunities for roots and tubers. In the coming half an hour, we'll have a little question and answer session and debate about this topic. Of course, the topic of climate change itself is very broad and has multiple angles to it. And of course, the roots and tuber crops, from the literature, we know that some of them may be better adapted, some may be less adapted to climate change, but definitely the whole climate change scenario and how it's going to impact on roots and tubers will have a huge footprint on funding and the efforts of science and investment for the coming decades. Of course, part of that is related to trends that are following climate change, temperature changes, changes in heat or drought, and that's something that different people are looking at. Entomologists, people looking at diseases, how the agroecologies will change, how the incidents will change, but of course also for breeders working on climate smart traits, heat tolerance, drought tolerance, it's an important topic. And not to forget that of course often one thing we mention about roots and tuber crops, that they are excellent resilience crops. I think sweet potato is a well-known example. After typhoons and after extreme events, we often claim that our roots and tuber crops are better fitted to fill in those gaps that surge right after a shock than compared to other crops. So plenty to talk about and plenty to kind of fuel the debate. But first, I want to introduce our speakers. We have here Graham Thiel, of course, the director of the CGIAR research program on roots, tubers, and bananas. We are still expecting Claude Fauquet, who is the director of the Global Cassava Partnership for the 21st Century. We have Kris Wyckhuys, who's a senior entomologist with CIHAT, based in Hanoi. And we have Lawrence Kent, who's a senior program advisor at the Bill and Melinda Gates Foundation. We hear a lot of talk and worries also about pests and diseases, and also in the models that I heard some concerns in some of the presentations yesterday, saying that maybe the models focus too much on the crops, but should also pay sufficient attention to pests and diseases. And that's what I'm going to ask our third invitee, Kris. What advances have been made till now in beating pest and disease related issues?
So we're little by little we're realizing that RTB crops, root and tuber crops, can sustain their yields under changing climates, or at least some of the RTB crops can sustain their yields. But pests and diseases are chipping away on those yields. So we're realizing here in Southeast Asia that in areas with extended drought, in areas with increased temperatures, we have more and more outbreaks of cassava witch's broom, of cassava mealybug, of cassava mites, and we've been responding to those. So we've been responding to those climate-triggered pests and diseases. Firstly, we've been developing diagnostic toolkits, ways in which we can diagnose the presence of certain hidden pathogens, such as cassava witch's broom phytoplasma. Ways in which we can detect the presence of the pathogen for the farmer when it's planted in the field, or for plant health authorities when planting material is moved from one area to another. A second way in which we've responded to those climate-triggered pests and diseases is in the setup of surveillance and monitoring networks. So we've really brought the whole Southeast Asia region together We set up a monitoring network with 6 different countries, in which over the past couple of years we've monitored hundreds of fields just to find out where are those pests and diseases moving, where are they causing tremendous problems, and where do they need intervention from a research side. A third way in which we've been responding to those climate-triggered pests and diseases is in predictive modeling, so forecasting. So we've developed a set of mathematical models that show, based upon the actual distribution of certain pests and diseases, and based upon climate change projections, where are those pests and diseases likely going to move to? So where are they going to cause problems 10 years from now, 20 years from now, under higher temperatures, under increased rainfall in certain areas. A fourth area in which we made quite some advances is in applied research. Applied research to look at resilient cropping systems, not only at the crop itself, but how can we grow the crop in such a way that it becomes less susceptible to climate-triggered pests and diseases. And one area that has received quite some attention from our research group is in cropping systems diversification. Some of the root and tuber crops currently are grown under monoculture arrangements. We see that monoculture crops are particularly susceptible to some of those climate-triggered pests. So we're evaluating polyculture arrangements. So we're looking at, if cassava is grown in an intercropping arrangement, does it become less susceptible to pest and disease attack? Do we create a bigger chance for biological control? And do we make the crop less susceptible to those emerging problems? And so we're looking at different cropping or intercrop arrangements. We're looking at different species of intercrops, and we're looking at ways in which to promote those with the farmers. Then a fifth area of 6, a fifth area of intervention is capacity building. 3 years ago, when I arrived here in Asia, there was very limited capacity in the region to respond to some of those emerging pest and disease threats. Very few trained, very few trained scientists in the national programs, very few people that knew how to deal with the invasive pests and diseases. So we've been organizing a whole set of workshops in the region, building critical capacity to respond to those novel problems. And then last but not least is farmer education programs. That has become really a key pillar of our program, and it's really training farmers on how to respond to those novel problems, how to respond to those problems that are becoming ever more severe under a changing climate, under an uncertain world, and on the farmer education angle, we've made strategic use of ICTs. So we've made strategic use of farmer-to-farmer training videos, working together with the private sector in delivering that to farmers, and in building critical capacity on the ground. Not only critical capacity in the research laboratory or in the classroom, but also in the field. And I think my answer was probably too long.
Yes, it was a bit longer, but very detailed. And thank you for making us realize that, particularly in this part of the world, there's already so much going on at this same moment, and there are many initiatives already in place.